So you're curious. I get it. You want to know about the big scientific breakthroughs, but wow, there's just so much information out there. It's easy to feel overloaded.
Absolutely. Information overload is real.
That's where we come in. Today, we're doing a deep dive into, well, one of the universe's absolute biggest mysteries, dark matter. And there's some really exciting, maybe even revolutionary news on how scientists are planning to actually find it.
It really is one of the fundamental puzzles. We know something is out there, something invisible, making up, what, 85% of all the mass?
Yeah, 85%. We see its gravitational pull, right?
Yeah.
How galaxies spin way too fast for the stars and gas we can see.
Exactly. And how light bends around, well, around apparently empty space. It's there, we just don't know what it is.
The universe's missing ingredient, basically. And for decades, the hunt's been on. One of the top candidates, maybe the top candidate, is this hypothetical particle called the axion.
Right, the axion. And the thing is, if axions exist, they're thought to be incredibly light, almost massless, and they interact very weakly with normal matter,
making them practically invisible ghosts flitting through everything. So hard to detect.
That's the core problem, isn't it? How do you find something that, barely acknowledges the rest of the universe?
Which brings us to this new idea, this new detector. They're calling it a cosmic car radio.
Yeah, it's a great analogy. It comes from a collaboration, King's College London, Harvard, UC Berkeley, other places. Really smart approach.
Okay, cosmic car radio. Let's unpack that. So the idea is axions might not just be particles, but they could also act like waves, like radio waves or light waves.
Precisely, part of the electromagnetic spectrum. But here's the catch.
We don't know the frequency.
Exactly. We have no idea what station the axion is broadcasting on. It could be anywhere in this huge frequency range, kilohertz all the way up to terahertz, a massive range to search.
So you need a radio that can tune across potentially all of those frequencies.
And that's essentially what this new detector aims to do. It uses a really specific type of material to create something they call an axion quasi-particle, an AQ.
An AQ, like a tiny custom-built antenna.
Sorta, yeah. Think of it like that. It's generated at the quantum level, and it can emit a very specific frequency. They can tune that frequency.
Okay, I think I see where this is going. So
Yeah.
this AQ is broadcasting its own frequency.
Right.
And if there are actual axion waves out there passing through, oscillating at their own frequency, if the AQ frequency and the axion frequency match up perfectly.
Bingo! Resonance. It's like hitting the right note to make a tuning fork vibrate.
So the AQ starts to resonate.
Exactly. And that resonance, according to the theory, should cause the AQ to emit a tiny amount of light. Really, really faint.
But detectable. That's the signal they're looking for, this faint flash of light when the frequencies match.
That's the hope. And what's particularly exciting for the researchers is that this AQ tech works way up at the high end of the spectrum, the terahertz frequencies.
And that's a promising place to look.
A lot of theories point there, yes. It's considered a really good bet for finding axions. One of the co-authors, Dr. David Marsh, put it nicely. He said, we can now build a dark matter detector that is essentially a cosmic car radio, tuning into the frequencies of the wider galaxy until we find the axion.
Wow. He added, we already have the technology, now it's just a matter of scale and time. That sounds optimistic.
It does. It really does.
So what is this magic material? The thing that lets them make this tunable AQ antenna?
It's a material called manganese bismuth telluride, Mn by euro.
Okay.
It's got these really interesting properties, electronic and magnetic. It's a bit complicated, but it behaves in unique ways at the atomic level, almost like it's both a conductor and a magnet under certain conditions.
And they have to prepare it specially.
Oh, yeah. They have to shave it down incredibly thin. We're talking just a few layers of atoms thick, two-dimensional layers stacked together.
That sounds unbelievably delicate. Any particular difficulties with that?
Definitely. The lead author, Jian Jiankyu, mentioned that this stuff, N by euro, it's apparently really sensitive to air.
Ah.
So to really see its fundamental quantum properties, how it might interact with something like an axion, they have to exfoliate it, peel it down to those few atomic layers, probably in a vacuum or controlled environment. That level of control is key to tuning it just right.
Makes sense.
Yeah.
Okay, so they have the concept, they have the material.
Yeah.
What's the timeline look like for this cosmic car radio actually starting the search?
Well, the team sounds pretty hopeful. They estimate maybe 5 years to scale up the process and build a larger working detector.
5 years to build it. Okay.
And then after that, Probably another decade, maybe 10 years of actually scanning, methodically tuning through those high terahertz frequencies, listening for that faint signal.
So 5 plus 10. We could be looking at a potential detection within, say, 15 years.
If things go to plan, yes, that's the time frame they're suggesting is possible.
15 years. You know, it sounds like a long time, but this search for dark matter, direct detection at least, has been going on for, what, 40 years? More?
Easy 40 years, yeah. Trying to find the axion specifically. So in that context, 15 years, it does feel like maybe we're getting to the final stretch.
What's driving that feeling? Just this new tech?
It's partly the tech, but also how theory and experiment are converging. Dr. Marsh also pointed out that the amount of research being published on axions right now, it's huge.
Oh, really?
Yeah, he said it reminds him of the buzz around the Higgs boson just before it was finally discovered. You know, theorists proposed that axions acted like a radio frequency in 1983, and we now know we can tune into it. We're closing in on the axion and fast.
That's quite a statement, closing in fast. And this research, the foundation for this detector, it was just published, right? Nature, April 16th, 2025. This is happening now.
Exactly. It's not science fiction. It's active research pushing the boundaries.
And I love how it brings together different fields, like advances in material science suddenly give astrophysicists a whole new tool to probe the universe.
That's often how breakthroughs happen, isn't it? Unexpected connections. The ingenuity here is really something.
Okay, so let's wrap this part up. We've been diving into this persistent mystery of dark matter and this really innovative cosmic car radio idea using this special material, manganese bismuth telluride, to create an axion quasi-particle, or AQ,
Right.
that can be tuned. And if its frequency matches the axion's frequency, boom, a tiny flash of light tells us it's there.
That's the essence of it, a potential path to finally identifying this stuff that makes up most of the universe's mass.
And the timeline, maybe within 15 years, could solve a puzzle that's been baffling scientists for decades.
It would be absolutely transformative for our understanding of, well, everything, cosmology, particle physics.
Which leads to a final thought, something to chew on. If they do find it, if we finally understand what dark matter is, what happens next? How does that rewrite the textbooks? What completely new questions will pop up once we solve this massive cosmic riddle? What else is lurking out there that we haven't even thought to ask about yet?